Now we can define the hardware set. In order to do this, we need to apply some work planes that will guide the position of the hardware units. So we can hide some of them for a while. Now double-click on the side panel and then use a plane tool to define the position of the work plane, which will be in the middle of the hardware set. The same can be done from the opposite side. Make sure that you are defining the distance, including the backplate position. Okay, so now we can use a join command to browse through the library of the components, and in between the fixed joints we will utilize the minifix. Quite commonly used object. So here we will choose a default configuration, and then to place the component we need to define where it will be resided. Just answer to the question by indicating where is the appropriate components. Okay, that's it. Now we can use the same component again, but in this case I will choose another set of the geometry items. So choose nested board, pillar board, and the axis plane. And then attach the components. Okay, now we can choose the components on the other side. Like that. Not try to apply them at one step, because it's easier to just split this operation in multiple steps and just choose the appropriate geometry. Otherwise you may get extensive amount of hardware items in all the intersections of the selected geometry components, which is not good. So the tactic here will be to just divide your workflow in multiple stages and just pick the geometry items for each of those stages, and that's it. So now you can see that there are some hardware items already on the place. So we can browse for a library, components, and choose the shelf holders. Again, there are some mounting instructions. So you need to indicate appropriate geometry, the side, the opposite side, the bottom of the shelf, and 2 axes. And that's it. Later we will multiply the amount of shelves. Now we can turn on the components that we have. So the door is visible again. You can double click to enable edit in place mode. And then we will define the position of the hinges for the door. So this work plane defines how far the hinge is resided from the top, and as well as from the bottom of the door. So we have 2 work planes, and the next one will define the position of the handle. Now we can have a work plane in the middle of 2 selected surfaces. This will be right in the middle of the door. So we have a horizontal work plane. Okay. Just hide the top and then use a touch. In this case, from the library we'll pick the hinges, conceal hinge, insert type, okay, and then we'll choose the front of the door, side, and the hinge center axis. So remember, we have 2 hinges, but you can have more than that. Just apply some additional work planes if you need to, and that's it. The hinge is on the place already. So we can make the top visible again. Now let's deal with the facade of the door. Again, the position of the handle can be defined by 2 work planes. One is in the middle, the second one defines the horizontal offset. Once it's done, we can use the touch command again to browse through the library structure in order to find handles. Choose appropriate length you prefer, and then you need to define you need to choose the mode. In this case we will pick a single mode, since we want to get one handle at a time, and then again pick the reference geometry, the front, the vertical and horizontal work planes, and the rotation axis. So the same handle can be used vertically. So in this case we will choose another length, pick the door plane and the vertical reference angle, and then 2 axes. As you may see, the handle is on the place already. Now we want to place some supports. Unit will be positioned correctly, even on some uneven floor. And then need to define where is the bottom of the unit. That's it. The sides of the supports and the axis. In this case it will be enough to choose only one axis, since we have picked the side of the board. Now it's time to fix the plinth on the place. Again, the work plane in the middle. Go back to the assembly level. Browse through the structure of library. Pick fixed join, minifix. Choose a configuration, and that's it. So now we need to just pick the appropriate geometry items, as we already did in the previous steps. There's the nested boards on the left, on the right, since we want to hide the joint, we will pick the invisible side, and finally the axis. The joint is on the place. Now we can use the parameters in order to link the parameters of our assembly with the parameters of our concept file. Since we want to multiply the amount of shells, we want to know what is distance and how many of them we will have. So there is the list of parameters that can be imported. Pick the one you want. This will be the distance between shelf and their amount. Now we can hide the door and choose a pattern. Pick the shelf together with supports, like that. Choose a rectangular pattern, and as a direction I would recommend to utilize the origin features. So in this case, pick one of the axes, which will be the z-axis, and then you need to define distance. Okay. Now we can make the door visible again. There is something left to do. We want to make the components invisible for a while, so we can choose a visibility control and hide all the panels with Woodwork for Inventor material assigned. Once it's done, there is time to choose the right configuration of the component by using Change Component option. So you can see now the dowel is on the right spot, on the right position, and this one can be used as a template to change the other items. So just click on the first, which will be treated as a template, and then click on the next that need to be the same by configuration as a template. It may take some time, but since each of the furniture unit may have a unique hardware set, there is no ways of automate it, since we are guided by our engineering experience. So once it's done, the components can be enabled again. And then we have finished the work with the hardware. So we are ready for the next step.